Okay, today problem is marked as hard. Let's look at the description. We have list of numbers and they represent some operations, like let's consider example like this given numbers and have some virtual array of zeros, and in one operation we choose some subarray and do +1, making all of the subarray +1. So they ask us to find the minimum number of operations to convert this zero array to this target. Look at the problem size. It has 10 to the power of 5 length and 10 to the power of 5 individual targets. So we can just brute force and like choose any subarray randomly, or I don't know how you can brute force, even if you have like 100 numbers, the brute force is choosing any subarray sequence, and it would be like n to the power of, I don't know, to the n. It would be big. And to solve this, I imagined these operations in my mind. Like, let's draw how you can do this. Let's abstract away numbers and just draw some, I don't know, circles like this. Each circle represents individual number, like this is 3, 2, 1, and 3. And for the optimal increase operation, I want to choose the best, the longest, like in the Tetris game. So I choose firstly this array and increased it. So this is a new level after this operation. Then I have no other choice but to choose these two subarrays. And finally, I choose those two. Then the total is 1, 2, 3, 4, 5 operations. And this is kind of algorithm that just visually explain them all. But I wasn't sure it is optimal. However, I don't have any other algorithm, so I tried to implement this. How can you implement this? You can't, again, you can't scan these levels, because the height of this pyramid is 10 to the power of 5, and the length is also 10 to the power of 5. You can't brute force it, it would be n squared. So you have to invent some linear solution, or maybe not linear, but n log n would be also accepted, but not n squared. So how can you find this linear solution? Let's again look at these operations, but now we have to look at the numbers. 3, 2, 1, 3. Imagine we have some linear algorithm. Let's assume we have it. So we have index I, and we know the current number. Okay. What we know else? Nothing more yet. let's just remember this number 3. So we have 3. Move the pointer and let's look at the number. The number is 2. What we know? We know first the current number is 2 and the previous number visited is 3. So let's draw it 2 and remember it. And what kind of knowledge we can derive from these like 2 memory points? We know that to increase the level, we only can increase by +1. So the 3 is at least +1 operations, or 3 +1 operations. And when we jump in from the level 3 to level 2, that means this kind of island the height of 3 is ended. So we have to jump down. And that means we have to remember this island. Let's just assume we didn't have to track it, but let's write it like we jump in from high level to lower level is -1 of the level. And let's remember it. We're doing -1 of the level. Let's go next. I is 1. And we jumped again from level 2 to level 1. And we entered the level 2 and jumped by the height of 1. Go next. And we started the new islands. How many of them? So we jumped from 1 up to the 3. And this is the +2 levels. And after that, we at the end of the array, and we can see that we have 3 levels going on, and they each jump to 0 because each island is end here. So this is like -3. So by looking at the numbers that have a negatives jumps, this is the ends of our arrays, or our islands. Let's look at them again. So we have 3, then 2, then 1, and then again 3. The kind of island is we can at each level connect these islands. And this is disconnected because it has absent value. So each island has end. And if we pay attention to this end, we can see that we can count the number of islands. The number of islands is a number of ends of each island. So this, how many ends we have? This is 1, 2, 3, 4, 5. And if you look at the number of islands is 1, 2, 3, 4, 5. So the algorithm is count the number of ends of each island. Count ends of each island. This is a greedy algorithm, and it is a linear algorithm. You just have to know the previous level and you increasing the number of operations is the number of islands, and finally you end with the final step. This is it. It is the optimal solution. So 1 in the memory space and of n in the time complexity. This isn't kind of a hard problem because it has a high acceptance rate, but this is expected because this problem kind of early days before inflation. Let's look at the hint. This is a segment tree or range minimum query. I don't know how I use this hint. It's a complex hint. The hint is harder than the problem. So that's it for today.